and this is a little wrong. I'm saying the Stigler-Becker model will make incorrect positive predictions. The truth of the matter is, and I'm not going to get into why, but Stigler and Becker wrote a model that doesn't make predictions at all because it just has too many free parameters, it has too many moving parts. They can predict anything, so it's incapable of pinning anything down. But Becker and Murphy came along 10 years later and wrote down a model of rational addiction. This is also a very famous paper that actually does make predictions. And it makes predictions about, basically it says people will only choose to start doing drugs if it's actually utility maximizing for them to take the risk of getting addicted and being miserable for the rest of their lives, right? And so they have this lovely model of how taking drugs now affects your preferences for taking drugs later on, making you want more later. And then they just sort of bolt on this assumption that people correctly predict the habit formation process. Therefore, if you chose to start doing heroin, it must have been because it was utility maximizing to you to face the risk of spending a lifetime, of looking like Keith Richards, or dying of heroin addiction overdose or something like that. So it's going to make the wrong predictions, but sorry, and I jumped from positive to normative in the middle of that. It's not just going to make the wrong predictions, right? So for example, given the extremely large health benefits of going to the gym regularly, and given the habit formation process in physical exercise, an initial investment of forcing yourself to go to the gym every day for a couple of months until you've actually formed the habit is almost certain to be utility maximizing for most humans, at least most sedentary humans. And yet huge numbers of people don't do it. So the positive prediction of the model would be, if there's habit formation, people will go to the gym initially in order to form a habit. The normative component is, if people correctly predict this habit formation process, then we don't have to worry about the possibility that they'll make mistakes. The people who go to the gym are the people who know perfectly well that they could form a habit, and they don't care. They love sitting on the couch so much that they're actually willing to forego a lifetime of health benefits, even knowing that if they went to the gym for a couple of months, they'd form a habit and love it. Okay, so normatively, we get to say, if we assume that people predict things correctly, we get to say, laissez-faire. Don't mess with things. People are making normatively optimal decisions already. Okay? And if in fact they fail to predict these state-dependent changes, then they may very well not be optimizing their own preferences. Okay. So let's take a look. I need to speed up because I need to get you to the model, or you're not going to be able to do the problem set. Okay, so let's just buzz through looking at some evidence. This is something that's remarkably difficult to get really unambiguous evidence about. But let's look at some stuff on temporary fluctuations, which has been so far the easiest to get a handle on. So hunger, okay? May not be economically important, but as with some of the stuff like the cab drivers, I said, look, we may not care that much about cab drivers and bicycle messengers, but it's very, very hard to find a real-world situation where you can actually pin down reference dependence and labor supply. So we look at it. And it's the same thing here. It's very hard to nail people down on misprediction. And sometimes with these temporary fluctuations, it's a bit easier. And then the other point, which is something that I think is really important here, is we go from being hungry to not hungry most days. If we're mispredicting that, even though we experience the change daily, like, why are you still mispredicting that? I mean, you guys are mostly in your early 20s. I'm in my early 40s. I've been hungry a lot of times. I still get it wrong. So that's weird. Okay, so there are these studies where people randomly give out candy bars to half of the people entering the supermarket, and then they monitor, they get their cash, they get their receipts, and they see how much people buy, and what they find is that if you give people a candy bar before they go shopping, they buy less food. Okay? Which suggests that when you're hungry, you tend to buy food as if you're going to be hungry all week. Okay? One possible explanation is that you're mispredicting. Or maybe it's that when you're not hungry because you just had a candy bar, you buy food as if you were going to be not hungry all week. We don't know which. The problem with this is that there's a possible alternative explanation, a confound, which is satiation, a very standard economic explanation, which is, hey, you just gave me a candy bar, I don't need as much food. You just gave me some free food. You just gave me $1.25 worth of free food. So if you see that my expenditures go down by $1.25 on average, duh, because you just gave me some food. Okay, so what's the solution? You know my answer, conduct a field experiment. And then after I'd written this slide, I realized, well, that's already a field experiment. So what I mean is, conduct a better field experiment. Oh, also, by the way, that word may doesn't show up in your handout. Okay, Reed and Van Loan in 1998 did the following, by now very famous, at least among behavioral economists, field experiment. They took a bunch of office workers and they said, we're going to give you a snack in 1 week. 1 week from today, we're going to give you a free snack, and you get to choose now whether you want it to be a healthy snack or an unhealthy snack. And I can't remember, the paper's got the range of different snacks. It was interesting stuff. And you're going to choose now for a week out. And then they randomized people along 2 dimensions. When they would make the choice, either right after lunch when they're satiated or later in the afternoon when they're hungry, and then when the snack would be delivered next week, either right after lunch when they'd be satiated or later in the afternoon when they'd be hungry. And they asked them to choose. And here's what they saw. This is the proportion choosing the unhealthy snack. Okay? So it turns out when people are hungry, they're more likely to want an unhealthy snack. So what we see is, if we compare the columns, one to the other, people who anticipated being hungry when the snack was delivered were more likely to choose an unhealthy snack, whether they were hungry or satiated, right? So if you knew that you were going to be hungry when you received the thing, you'd be more likely to choose an unhealthy snack than if you predicted that you would be satiated. Whether you're hungry or satiated now or not doesn't matter. Okay, so 78% bigger than 56%, 42 bigger than 26 means that regardless of my state now, I correctly foresee that in the future I'll want an unhealthy snack. Okay, so they get the direction right. But they're off by how much, right? So if we compare the rows, right, if I'm choosing for a time when I know I'll be hungry, if I'm hungry now, I'm dramatically more likely to say an unhealthy snack than if I'm currently satiated. Now, that looks like it's probably because the satiated person is under-predicting how much they'll want an unhealthy snack, okay? And similarly, when I'm hungry now, I think that I know that when I'm satiated, I'm a little bit less likely to want an unhealthy snack, but I don't realize how much less likely I'll really be. I'm still more likely to say unhealthy than I would if I were currently satiated, predicting for a time period when I will be in the same satiated state. Okay? So the general pattern here, which is going to be consistent, is people typically seem to get the direction of state-dependent preference change right, but they don't realize how much the change is going to be. Okay? So they predict that their preferences will be somewhere in between their current preferences and their actual future preferences. Okay? So I just skipped that. I didn't skip it. I said that without clicking it. Okay? So they seem to predict the direction, but not the magnitude. This is in the problem set. Giordano et al., and part of it all is George Lowenstein. You can count on a fun experiment if George Lowenstein is involved. They got a bunch of heroin addicts at a heroin treatment clinic. It's really hard to get people off heroin. It's even harder to keep them off. And so one of the things that typically gets done is you give them a heroin replacement that doesn't make them high, but makes them feel a lot better because it takes away the craving. And so this stuff is called BOOP, B-U-P, it's pronounced BOOP. So these subjects are going to be given, and I think this was just sort of standard practice, a base dose of BOOP on day 1 and day 5. I think it was like they got it twice a week or something like that. I don't remember. And then the experiment is to elicit their willingness to pay for a second dose of BOOP on that 5th day. And they're going to randomize people into 4 different groups as to when they take that elicitation, when they ask you for your willingness to pay. Is it going to be on day 1 or day 5? And is it going to be before or after the base dose? So if it's before the base dose, you're going to be deprived, and if it's after the base dose, you're going to be satiated. Okay, so we've got a time dimension and we've got a state dimension. And what do they find? This is the median willingness to pay across the addicts in these different categories. And in some sense, we can think of you're going to get the base dose when you're satiated. I'm sorry, you're going to get the second dose when you're satiated in day 5. So let's go to day 5 and ask people what their willingness to pay is when they're satiated. $50. That seems to be the true value of a second dose of boop. Okay? And then they appear to have present bias preferences because in day 1, whether they're deprived or satiated, they're willing to pay less on day 1 because it's just 5 days out. Okay? But then what we want to look at is they also appear to mispredict this state dependence. So if we compare the top row to the bottom row, right, what we see is that if you ask the person on day 5, there's no time discounting now. They ask right before the base dose, right after the base dose. The difference here is if I'm in a deprived state, boy, I really want that first dose of boop because I'm in a state of craving. I don't know how many of you have ever been or seen a heroin addict in a state of craving. It is not a pretty sight. It is incredibly unpleasant. It is among the most unpleasant experiences you can have as a human being. They're willing to pay $75 for that first, they think they're going to be willing to pay $75 for that second dose, probably because they're sitting there thinking, oh my God, I love boop, I got to have my boop. Yes, I'll pay anything for a second dose. When what's really going on is that they'll pay anything for the first dose. And they're projecting that set of preferences onto their satiated self. Okay? So this would be sort of a way to extort money out of heroin addicts. So that's the same pattern, okay? And we see the same thing in a lot of other areas. Dan Ariely's done this crazy research where when men are more aroused, they fail to predict how, when men are not aroused, they fail to predict how they'll behave when they are aroused. That study is on B-Space. You will be horrified to find out what it is that men will do when they're aroused that they think they won't do. Whoops. Similarly, and this is up there too, this is really lovely, shoppers on cold days, not in winter, but before winter, this is like from LL Bean or something, on very cold days, shoppers will not only buy more warm clothing, they will buy and then return more than on regular days. Okay, so on cold days, they think, oh my God, I've got to really beef up on sweaters and jackets, and then they find out, no, I was wrong, I don't need that, and they send it back. Okay, shoot. I'm going to skip this. It's basically just about, we kind of talked about this already at one point. Take a look at this in particular. This is basically, I referred to this earlier, people completely fail to predict that people roughly get right the idea that if you become a paraplegic, right, which means your legs are paralyzed, that it really sucks, that you'll be in a bad mood more often than you're in a good mood. But what they fail to predict is that you actually get used to that after about a year, and you may be bummed out, but you're not nearly as bummed out as you were at first. And similarly with lottery winners, people correctly predict that shortly after winning the lottery, you'll be in a good mood much more often than being in a bad mood, but they sort of fail to predict how quickly you get used to that. And so where they're trying to pick that up is they're saying, this yes column is people who said yes to the question, have you ever known anybody who was a paraplegic? And this is people who said yes to, have you ever known a lottery winner? Okay, so they're sort of taking that as a better estimate of the truth, and then looking at what people who said no to that question predicted as to how often you'll be in a bad mood or a good mood 1 month or 1 year after. Right? And so people seem to get roughly correct the immediate effect, but they completely fail to, well not completely, but they largely fail to see this adaptation process coming. They don't predict it. So that's a little bit like habit formation in some sense, right? Okay. Let me crank up this model. I'm not going to rush too much. I won't get through it, but I want you to actually see the math of the model so you can go and sink your teeth into the problem set. So the key psychological finding, as I pointed out already, is that people appear to predict the direction of state-dependent preference change fairly accurately, but they fail to predict the magnitude of the change. Now, I don't claim that there aren't any situations in which people get the direction wrong, but by and large, people seem to get the direction right. People seem to get that when they're hungry, they're going to want food more than when they're not. Okay? So they violate rational expectations with respect to state dependence. And we're going to refer to that phenomenon as projection bias, because what we think is going on is that when people are predicting their future instantaneous utility function over outcomes, they take, so I'm in one state now, I know what my preferences are now, I'm predicting what my preferences will be when I'm in a different state, and what people typically do is they take the shape of their utility function now and they kind of project it onto their future selves. They know what the state will be that they're going to be in, and they know what their instantaneous utility function will be. This is kind of hokey, but this is the way the model is going to look. But they're sort of going to, their prediction is going to be some kind of blend of how they feel about, you know, what their preferences are now and what their preferences are going to be, and they kind of get the direction of change right, but they don't fully appreciate how much their preferences are going to change. So they're going to take their current preferences and kind of project them forward to some extent. Total projection bias would be a complete failure to predict any change and just a feeling of like, no, I would die for a dose of boop now, and even if you give me a bunch of boop, I still would die for a dose of boop. Okay? And then partial projection bias would be something less than that. So here's the model. First we have to model the state dependence itself. So first we need the instantaneous utility at time t to be a function both of your consumption, which could be a lot of different things, and some state s of t. So we're just going to have this thing, which we've seen before, right? Like if this is what we did with reference dependence, where s was your reference point. Okay, so it could be anything. S could be your level of hunger, your level of habituation, your reference point, whatever. Then we're going to introduce the projection bias. So from the perspective of period t, looking forward to some future period tau, okay, the individual believes that their future instantaneous utility will be as follows. So this is their belief, u wiggle. This is their prediction. I know it's supposed to be u tilde, but most economists say u wiggle. So I'm going to say I'm predicting my preferences over the actual consumption that I will get in the future, or the choices that I know I'll be faced with in the future. That's C of tau, the real future consumption, given the state that I will actually be in the future, but also given the state I'm in now. And so this is my prediction of my future state-dependent preferences, given what my state is now, S of t. And what it's going to be is I'm going to take this thing here, right? This is my instantaneous utility function over my actual. This is how I will actually feel about the consumption I'll have in the future, given my actual state in the future. This piece, so that's this. This piece here is my preferences, the preferences I would have in the future over my future consumption if I were still in the same state in the future that I'm in now, right? If my state didn't change, if my state were S of t, not S of tau. So that's this piece, how I would feel about C of tau if my current state S of t persisted. And then there's going to be some alpha between 0 and 1, and I'm just going to weight these two things, right? So if alpha is 0, what does that mean? If alpha is 0, this piece goes away, right? If that's 0, and it's just me correctly predicting what my true future state-dependent preferences actually will be, okay? And that means no projection bias. If alpha is 1, then that means this part goes away, right? 1 minus 1, 0. And that's just me predicting that my future preferences will be exactly the same as my current preferences. That's total projection bias, okay? Now you can probably already guess that there are going to be some similarities between this and the beta-delta model, right? So you can see that if alpha is 1, it's going to look a lot like I just completely ignore the future in some sense, or it's going to have some of the same flavor. Okay, and then they just take this thing, this alpha mixture of current state and future state preferences, and they use that, and they say, that's what I think my future preferences are going to be, so I'm now going to choose my favorite plan based on summing that up over all periods. Okay? So they're just going to take this u wiggle, and they're going to plug it in, you know, here and here. Okay? Over and over again, in lots and lots of different modeling situations. Okay. So I got 3 minutes. I'm going to run you through a super hokey, super simple example so you can just see this in action one time. willingness to pay for a hamburger. So this is hunger-dependent preferences. Okay? So burgers B and money Y, which is to say that their consumption, C of T, is actually a vector. Consumption of burgers, consumption of money. Okay? And then their preferences are going to depend upon their state, which is going to be, so you know that if I say H is in a set of curly brackets, that means it's either 0 or 1, whereas if it was square brackets, it would mean it's between 0 and 1. So HT is either 0 or 1. So you may be either hungry HT equals 1 or not hungry HT equals 0. Super simple model. And so your state-dependent instantaneous utility function is a function of both your consumption vector BT, YT, and also your hunger state HT. And it's going to be this. If your hunger state is 0, you're not hungry, then it's just 1 euro per burger, 1 euro per dollar, which is another way of saying you're willing to pay $1 for a burger, right, when you're not hungry. If you are hungry, 1, then it's 5 euros for a burger, 1 euro for a dollar, which means that you're willing to pay $5 for a burger when you're hungry. Right? So this seems pretty realistic. You can think about a burger when you're not hungry as like a second dose of poop. All right, let's suppose that alpha equals 0.75, so that's someone who sort of has three-quarters projection bias. What is their willingness to pay when they're not hungry for a burger that they will eat later, right? So I don't know if any of you watched Popeye on Nickelodeon growing up. You remember the Wimpy character who always used to go around saying, I would gladly pay you Tuesday for a hamburger today. Then what we're going to want to know is how much would Wimpy pay you? Well, I guess that's, I would gladly pay you now for a hamburger Tuesday. So this is the opposite of Wimpy. Do you guys all know that in England there's a burger chain called Wimpy's? Would never fly in this country. Okay, so their perceived instantaneous utility function, this U wiggle, right, as a function of the burgers they're going to get on Tuesday, the income that they're going to wind up with on Tuesday, or the money, and the state of hunger that they're going to be in on Tuesday. Okay. Now we're saying we're willing to pay when they're not hungry. So H tau, this is going to be 0 for real. But they're hungry now, so HT is 1. Okay? And, whoops, I'm supposed to write that down. Let me find my math. See, I was supposed to have written it down on my notes, but I didn't. So what is it? It's alpha times U of B tau Y tau 0, because that's my state now, plus 1 minus alpha times U of B tau Y tau 1, which is my current state, right? No, my future state, when I am hungry. And that is equal to 0.75 times BT plus YT plus 0.25 times 5 BT plus YT. Sorry, those should not be T's, those should all be taus. And if you do the algebra, what you get is that turns out to be 2B tau plus Y tau, which means that this person's willingness to pay now, when they're not hungry, for a hamburger in the future when they will be hungry, is only $2. And when if someone says, all right, I'll give you a hamburger now for free, they're going to say no. And then when they get to Tuesday and they're hungry, they're going to say, I was a moron. I mispredicted my preferences. I should have said yes to a $3 burger. I'm kicking myself. If I could go back in time, I would change my choice. Okay? And that's what we're going to be looking at next time.